In the last video, we spent some time solving literal equations, so equations with more than one variable, and we just solved for the variable. So now we're going to look at what are ratios and how can we solve for a missing piece of a ratio by creating a proportion. So before we dive into that, let's just review what we did in the last video of solving literal equations, because this is difficult and it gets easier with the more we practice. And number one, we have the following equation here, 3g plus h is equal to 10, and our goal is to solve for h. So all I have to do in this one would be to subtract 3g to both sides, because that's the only thing that's by h, and this cancels. I'm left with h is equal to 10 minus 3g. Ooh, number two, we've got a fraction. This is an intense one, so I'm solving for L. So first I want to get things away from L that aren't like attached to it through multiplication. So I would want to subtract the b first. So right now I have a minus b is equal to 1/2 p times L. So now I'd want to get rid of the 1/2. Remember that when you have a fraction attached through multiplication, to get rid of it, we multiply simply by its reciprocal, so that 2 over 1 or just 2. So this cancels. Multiply this side by 2. Okay, now I'm multiplying this whole thing by 2. So I would actually rewrite that as 2 and then in parentheses a minus b. Whoops. A minus b is equal to p and then L. And then finally, the only thing by the L is the p, so I would divide everything by p. And so my final answer over here, so this cancels. This whole thing is what L is equal to. So I'm going to rewrite that as p equals 2 parentheses a minus b, because that whole thing had to get multiplied by 2. And then the whole thing gets, oh, hold on. Sorry, I realized I put p over there. P was supposed to go here. I didn't mean to confuse you. Let's try that again. So this would be L. Simple mistake. L is equal to that. Maybe. So let's look at, well, what are ratios and how do we solve them? So a ratio is simply a comparison of two numbers through division. Okay, I'll just put the division sign. So we can actually write a ratio in 3 different ways. So if I was saying that the ratio of boys to girls in the class was 3 to 4, I could write it like this, 3 and then colon 4. I could actually write it out as 3 to 4, or I can write it as a fraction as 3 over 4. And a proportion is simply setting two ratios equal to each other. So two ratios that are equal to each other. So an example of that might be 1/2 is equal to 2/4, or 3/5 is equal to 9 over 15. Now something cool about proportions is that their cross products are equal to each other. So if I did 2 times 2, that gives me 4. Well, same with 4 times 1. So that's how I know something is proportional. So again, if I did 3 times 15, that would give me 45. Well, so would 5 times 9. So we use that bit of information to solve proportions. So looking at our first couple examples, it says a person makes 6 long-distance calls and 15 local calls in a month. Okay, so number one, we're just going to get practice with writing a ratio. So number one says find the ratio of long-distance calls to local. So long distance were 6, local were 15. So that's one way to write it. I could write 6 to 15, or I can write 6 over 15. Now you have to be careful because I can reduce this just like a fraction. They're both divisible by 3, which makes it 2 over 5, or 2 colon 5, or 2 to 5. In number 2, it says find the ratio of long distance calls to all of the calls. So long distance was 6. Altogether, I would do 6 plus 15, which gives me 21. So 6 to 21. Now I can reduce that. So before I write it in all three ways, let's reduce it. They're both divisible by 3, which would make it 3. Oh, sorry. Which would make it 2 to 7. Okay, or 2 to 7, or 2 or 7. So always remember to simplify your ratio. So when solving, like I said, we can use that fact that their cross products are equal to each other to solve for a missing piece. So in number 3, I would just, I'm trying to solve for y. So I would start by cross multiplying. So 15 times 3 is 45. And then I set that equal to, because they're supposed to be equal to, and then 5 times y, so that would be 5 and y. Ironically, this is one of the examples I wrote down. So I would go ahead and just divide both sides by 5, so that y is then equal to 9. Now we can make it a bit more complex by inserting an expression in for one of the denominators and the numerators. So in this case, I have x plus 3 in my denominator. I'm going to cross multiply with the 30. Now when I do that, this is important. I use a set of parentheses because the x, because the x plus 3, the whole thing is getting multiplied by 30. And then 10 times 24 is 240. So now I can go ahead and distribute my 30. So I get 30x plus 90 is equal to 240. I'll subtract 90 to both sides. And I get 30x is equal to 150. And then we'll divide both sides by 30. And x is equal to 5. And then why don't you guys try number 5 on your own? So, you know what I didn't even notice about number 5 is that we've got variables on this denominator as well as this one. So that's going to mean that we're going to have variables on both sides. So when we cross multiply, you get 7 times b plus 6 is equal to, and then 3 times b, which is just 3b. Now I'll distribute the 7, so that gives me 7b plus 42 is equal to 3b. Now normally, I always talked about in my last video how I want to keep my coefficients positive. Naturally, I would move the 3b over, but then I have nothing left on the right-hand side. So instead, I'll subtract 7b to both sides. I'm left with 42 is equal to negative 4b. And then I'll divide both sides by negative 4. Let's see, 42 divided by negative 4 is going to give me negative 10.5. So how can we apply this to some real life scenarios? So in number 6, it says at a book sale, 6 books cost $13. Okay, so they're comparing books to costs. Remember, that's how we get ratios. So I would say, okay, 6 books costs $13. So assuming at the same rate, how many books, okay, so that was on the top when I compared books to price, could you buy for $32.50? So there's how I would set up my proportion. You could also flip those numbers. You could have had 13 over 6 is equal to 32.50 over x, but what's the most important is that you're keeping your units the same. So at the top are books, at the bottom is money. So from here, I'll go ahead and I'll cross multiply. So 13 times x is 13x, and then 6 times 32.50 is 195. And then I will just divide both sides by 13. And x is equal to 15. So 15 books. Always use units. Then in number 7, it says to feed your plants, you need to mix 3 tablespoons of plant food with 16 ounces of water. So there's my 2 comparisons, tablespoons to water. So right away, I'm just going to say, okay, 3 tablespoons to 16 ounces of water. If it takes 80 ounces of water to feed all your plants, how many tablespoons? Well, if I don't know that, I'm going to put that on the numerator, because that's where I have my tablespoons of plant food, all over 80. Then I can go ahead and I can cross multiply. So I get 16x is equal to, and then 3 times 80 is 240. So that's what I did here. And then I'll divide that by 16. And that gives me a value of 15, and that would be 15 tablespoons. And then finally, number 8. So one of the most commonly used reasons for poor proportions is scaling something. So an architect creates a scale model of a school. The actual school, so like in real life, is 50 feet high. The scale of the model to the actual school is 1 foot in real life. 1 foot on the scale is equivalent to 75 in real life. So estimate the height of the model. So if I have 1 foot in the model is equivalent to 75. So let's put model and then RL for real life. And we want to know, well, how much would my model be if it's 50 in real life? Okay, so go ahead and cross multiply, get 75x is equal to 50 times 1 is 50. Then I'll divide both sides by 75, and x is equal to, let me do this really quick just to make sure, 50 divided by 75. Whoops, let's try that again. 50 divided by 75. Okay, is going to be 0.67 if I'm rounding, because it was really 0.6 repeating. And that's kind of one of those decimals you should kind of memorize as 2/3. But I would accept any of those answers. But I would definitely want to make sure you have your units, which is feet.